Okay, so I started off with this. I also am going to point out that there was no need to write 9 here. There were, is it not autofill? Yeah, there you go. There are only 8 of the colored nodes. And I copy this here, keeping the clouded components there, remembering I could still, source transform the 7 volts and the 10K if I needed to. And I source transformed this. Maybe this is the hardest one. Let me start on the right side. So there's 8 kilo ohms here. If you source transform 8 kilo ohms, it continues to be 8 kilo ohms. It's here. But this voltage here equals IR, which is 8K, times the 10 milli, which is 80 volts. The same thing I did with many other of these current supplies in parallel with the resistors. So this one I copied. Between 8 and 6, you see here I copied the 4 and the 12. Between 4 and 5, I did the parallel between 30 and 20, which is 12. So this is the 12K. And then 8 milli going up and 3 milli going down means 5 milli going up. 5 milli times 12K is 60 volts. And because it's going up, the plus is on the top side here. So wherever the arrow is where our plus is. And this 30 is with the 15K. So this 15K I copied here, and the 2 milli has the arrow going to the node 6, so the plus is on node 6. And the 30 volts is 15K times 2 milli. So I did that. This between 4 and 3 I copied the 9 volts and the 3 kilo ohms. And between 3 and 2 I did the same thing, source transformed this. Between 2 and 1 I source transformed this dependent source into another dependent source, so it's still dependent on Vx, but I multiplied by 1K, so 2 milli times 1 kilo ohm is 2 times Vx. 2 milli times Vx times 1K is 2 Vx. So already I hope you see how much simpler this is, because now I have only voltage supplies in series. So now I'm going to pause and draw another circuit where I'm going to add all these guys, and I'm going to add these, and I'm going to add these. I don't think I can add these here. These are not in series, because here in 5 there is the Vx, so I can't add these two. So this is probably going to be my simplest circuit. Let's see how it's going to be. Okay, so I hope this is recording. Is that true? Anyway, I hope it is. So here I drew the last circuit, and hopefully you see how much simpler it is than this one. And yet it keeps the Vx, which is what we're interested in. Well, we need Vx because of this and this. And then I also kept the 7 volts and the 10 kilo ohms, even though we could have transformed that too. And from here to here, there's no source transformation. It is only adding power supplies. For example, this is 2 Vx. I would have written 2 Vx plus 20 volts, because the 20 volts is in the same direction as this 2 Vx. But you see how the 25 volts is in the wrong direction. So it's, opposite to 20. So that's how I wrote here 2 Vx minus 5 volts. This is how I got that one. Now let's see the 4 Vx. I also got started by drawing the same 4 Vx here. So you see I just, slid it to the side, but it's 4 Vx. And then it's the same direction as the 80 volts. So I just wrote 4 Vx plus 80. And then the resistor, I added 12K with 8K and got 20K. I did the same thing down here. These 5K are 3 plus 2. And up here, this 11K is 1 kilo ohm plus 4 plus 6. So now I just put the 11 here. So hopefully this last, step here, it's easier. And now you see how we only have 3 meshes, while here, if we had counted the number of meshes, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 meshes. So from 11 to 3. You could say this is a much simpler circuit to solve, right? If you are going to do superposition also, it'll be 1, 2, 3, 4 circuits. You can't use these for superposition, so it's 4 circuits to solve. If you're doing nodal, oh, there's a lot of supernodes here. I would have to count, but there's, let me see, 1, 2, 3, 4, 5, 6 voltage supplies plus ground, so it's -7. However many nodes, -7 would be the number of KVLs. I hope this helps with source transformation. And I also hope that this circuit here is easy enough. It's not easy, it's tractable enough using any of the methods that we have learned in 285.